This is Lab 3 for Physics 1 dealing with orbital motion. The purpose of this lab is to observe one or more objects in orbit around another object or two other objects, and to observe how the force of gravity interacts between the objects and what that motion will look like. And so our primary principles are going to be the force of gravity equation, which is given by gmm over r squared, where g is the gravitational constant, m's are the masses of the objects involved, and r is the distance between them. And then we're going to be using the velocity and position update so we can actually calculate a path that it will be traveling. And we're hoping to get something at the simplest level that looks like what we have here in the center, with one object orbiting around another. Our first part of the model had a star, which is our system, orbiting a black hole, which is the surroundings or the source of our gravity. On the left here, we modeled how to calculate the perpendicular and parallel components of the change in momentum and net force, and then using that, setting our gravitational force against F net and rearranging it for the mass of the black hole, we can solve for the mass of the black hole, which for an average we got out 7.01 times 10 to the 47th, which is larger than, in kilograms, is larger than any known black hole in the universe. For our second model, we had a rocket orbiting around a moon and planet, and the moon is also orbiting around the planet. And so there are various systems in here. Each one is a system of itself that has surroundings, as all three interact with each other, with the planet applying forces on both the ship and moon, and the moon and ship applying forces on each other. On the left here we have those forces written out in the code, with gravity given between the moon, planet, the moon and ship, the ship and the planet, and the ship and the moon. And then calculated up to Fnet, and we used velocity and position updates to create a path. And so the objective was to find what velocity would allow the rocket to orbit both the moon and the planet and not crash, and what I found was given by 1.8849 times 10 to the fourth in the x component and 2.55 times 10 to the fourth in the y component. And that gave us this pretty neat orbit that's seen here, where the rocket stays pretty close to the moon, so it's constantly pulling it. The rocket falls underneath the moon's orbit, and then the moon's gravity pulls it back out above its orbit. And we have this continuous playing. And even when this is modeled out further, this pattern continues without the rocket ever crashing. So discussion, what if? Well, if we were to try and model all four components together, the black hole, the star orbiting around the black hole, the planet orbiting around the star, and the moon orbiting around the planet, excuse me, five components, because then we have a rocket orbiting around the moon and planet. First off, it's going to be very intensive, modeling five different objects, applying forces all on each other. In order to model this, you would then have to calculate the forces being applied on each object as if each object is its own system and the other forces are all the other objects are all the surroundings, each of them applying force. So the star, planet, moon, and ship would all apply forces on a black hole. Likewise for the star, planet, moon, and ship. For the dominant interactions would probably be the black hole, as that will still be like the center of mass that everything orbits around, potentially. However, its distance from others could make it so it's not as perceived. The moon would probably still play a big factor in terms of the ship, whereas if you have the moon and planet line up just right with the velocity of the ship, then it could slingshot it out, and then if it further lines up right with the star and black hole, all that could slingshot it away. Of course, if you have anything wrong, the whole system could just tear itself apart, slingshotting components out until perhaps it's just two left orbiting each other. What does it mean? Well, so net force is a force applied to an object from another object from the source to the system, whereas momentum is something that is inherent to an object without having any other objects affecting it. Momentum is simply just velocity times mass. It's inherent. Um, the parallel component deals with how your speed is affected, and perpendicular changes the direction. So F-net perpendicular will change direction, F-net parallel will change speed, and that's how that works. Thank you.